linear programming problem. You find out this one. So one question is given here. A manufacturer of leather belts makes three types of belts, A, B, and C, which are processed on three machines, M1, M2, and M3. Belt A requires 2 hours on machine M1 and 3 hours on machine M3. Belt B requires 3 hours on machine M1, 2 hours on machine M2, and 2 hours on machine M3. And belt C requires 5 hours on machine M2 and 4 hours on machine M3. There are 8 hours of time per day available on machine M1, 10 hours of time per day available on machine M2, and 15 hours of time per day available on machine M3. The profit gained from belt A is rupees 3 per unit, from belt B is rupees 5 per unit, and belt C is rupees 4 per unit. So first one is formulate the linear programming problem. Okay, so first we shall formulate how to formulate this problem with the given data. So here you see here machines are what, M1, M2, M3, and bells are what, A, B, C. So first question is, this problem is on maximization problem or minimization problem, how to check? So one line you see, the profit gained from belt A is rupees 3. So here mention profit, so this is the problem of maximization. Okay, so first for formulation of linear programming problem, first we check here what will be its objective function and what will be its constraint. Okay, so there are three machines and belts of type A, B, C. So first check, for belt A requires 2 hours on machine M1 and 3 hours on machine M3. So here you see in machine M2 here 0. Here machine M2 is absent, means 0. So I have given the table, you see machines and belts. In machines I have written M1, M2, M3, and belt I have written A, B, C. So from here you see, for machine M1 take 2 hours time, for machine M3 3, and machine M2 is absent, so 0. Next one will be what, for machine type of belt B. So machine M1 will be here 3, and machine M2 will be here 2, and machine M3 is here uh, again 2. For belt of type C, here machine M1 is 0 and machine M2 is 5 and machine M3 is 4. Okay, just a minute. Wait, just 1 minute. Arbas? Okay. So here you see, for machine for belt C, here for machine M1 is absent, so M2 is 5 and M3 is 4. Okay, next is given the profit gain from belt A is rupees 3 per unit. Means what, profit for one belt, profit is for machine for belt A type, profit is rupees 3. For B type belt, profit is 5, and C type belt, profit is 4. So I have written. And next one is what, some restrictions are given. Restrictions are what, there are 8 hours of time per day available on machine M1. Means machine M1 works 8 hours, maximum 8 hours, and machine B2 works M3 works here 15 hours. Okay, so this is the formulation. You see this table is clear or not? Arif, you see the table?
Yes, sir.
Abhilasha, clear this table.
Yes, sir.
So from this table, we can also write directly. Okay, we can also write directly what will be its objective function. Objective function means what? From where we get the objective function? In this table, from where we get the objective function? Arbaj, in this table, from where we shall get the objective function? টেবল যোনটো দিয়া আছে তাৰ পৰা আমি অবজেক্টিভ ফাংচন কোনটো পাম কোৱাচোন? না, no. Objective, in objective function there will be some restriction. Objective function. Objective function always we shall get from the profit. You see the last column. For belt of type A, profit is 3. For per unit belt, profit is 3. And per unit of belt B, profit is 5, and per unit of belt of type C, profit is 4. So if we consider x1 be the number of belts of type A, x2 be the number of belts of type B, and x3 be the number of belts of type C, then here profit for one unit belt of type profit on one belt of type A, if rupees is 3, then x1 number of belts of type A will be 3x1. Similarly, for belt B type belt, profit will be 5x2, and belt C will be profit will be 4x3. Okay, so here total profit will be what? Total profit will be 3x1 plus 5x2 plus 4x3. So you see this is clear or not? Okay. And next one will be the restriction. So here restrictions are given here what? In M1, mean machine M1, machine M2 and machine M3. So in machine M1, there is some restriction for belt of type A 2 hours working 2 hours, for B 3 hours, and there is C is absent, so 0. So here maximum hours will be machine M1 can work maximum 8 hours. So here total will be what? Twice x1 plus 3x2 less than or equal to 8. Similarly, for machine for belt of type B, here this one will be twice x2 plus 5x3, because x1 is absent. So 0 into x1 is 0. So twice x2 plus 5x3 less than or equal to 10. And for machine restriction in machine M3, 3x1 plus twice x2 plus 4x3 less than or equal to 15. So this is the our constraint. Next one will be what? What will be the means values of x1, x2 and x3? What is the restriction of x1, x2 and x3? Yes, excel হুম আচ্ছা আচ্ছা ও ও you just hello.
Yes, sir.
So here what will be the restriction of the variable x1 x2 and x3? What will be the restriction? X1 and x2 and x3 will be what? This is
Greater,
greater than or equal to 0. So why greater than or equal to 0?
they cannot be non-negative.
Yes, because what is x1? X1 means what? Number of bells. Okay, so number of bells cannot be negative. So x1, x2, x3 greater than or equal to 0. So lastly, you see the linear programming problem of the given problem is as follows: maximize z equal to 3x1 plus 5x2 plus 4x3 and subject to the constraint this, and last x1 comma x2 comma x3 greater than or equal to 0. So here you see, here objective function, which one is the objective function? Which one is the objective function? Yes, means 3x1 plus 5x2 plus 4x3. Okay, and constant are, this is the constant. And what is x1 and x2 and x3? What is the name? X1, X2, X3 are called name is what? Which variable?
These are
Uh,
the
no, no, bells, number of bells, but
decision
standard
making.
name is what? Yes,
This
decision variable. Good. This is called the decision variable. Generally what? When suppose some linear equation is given, x plus y equal to 0, x minus y equal to suppose 2, then x and y are called, this is the variable or sometimes called unknown. But in linear programming problem, this is called the variable, but name is called, this is the decision variable. And next, you see, this problem, can we solve it by graphically? Yesterday I discussed how to solve, I mean, which problem we shall solve it by graphically and which one is solve it by simplex method. So can we solve this by graphically?
No, sir, because there are three variables.
Yes, good, Ishita. Because there are three variables, so we cannot solve it by graphically. So we shall solve it by algebraic method. Name of this method is called simplex method. Okay, so next problem is also I have given. You will see same way. A manufacturer of a line of patent medicines is preparing a production plant on machines A and B. There are sufficient ingredients available to make 20,000 bottles of A and 40,000 bottles, yes, bottles of A and 40,000 bottles of B, but there are only 45,000 bottles into which either of the medicine can be put. Furthermore, it takes 3 hours to prepare enough material to fill 1,000 bottles of A, and it takes 1 hour to prepare enough material to fill 1,000 bottles of B, and 66 hours available for this operation. The profit is 8 per bottle for A and 7 per bottle of B. So formulate the problem as a linear programming problem. So first we formulate and then solve. Okay. So this is same way uh, you consider for manufacturer produce X1 and X2 bottles of medicine A and B respectively. Okay, so profit on one bottle here given you see 8 rupees. So x1 bottle will be what? 8x1. Similarly, for one bottle of medicine B, profit is 7. So similarly, we consider x2 number of bottles. So this is 7x2. So total profit will be sum of this. So sum of this we just consider Z. So Z equal to 8x1 plus 7x2. Next one is what? Time required to produce x1 bottles of medicine A is, here this one is what? This is given, you see question is one line is, furthermore it takes 3 hours to prepare enough material to fill 1,000 bottles of a. So 3 hours to prepare enough bottle to fill means 1,000 bottles of a, means for 1,000 for bottle A, 1,000 bottles when we fill, it takes time 3 hours. Therefore one bottle, this is 3 by 1,000. So x1 number of bottles will be 3x1 by 1,000. So this is directly I have written 3x1 by 1,000 hours. So you see this is clear or not? 3x1 by 1,000 hours. Clear, Arbaj? Okay. So similarly, for bottle B, it take times means 1 hours. So 1,000 bottles for type of means 1 hour. So x1 number of bottles will be x2 number of bottles will be x2 by 1,000. And next, there is some restriction will be what? The total time required to prepare x1 bottles of medicine A and x2 bottles of medicine A is 66 hours. So this is less than or equal to 66, and then cross multiplication we get this. And next restriction is what? There are only 45,000 bottles into which the medicine can be put. Means x1 plus x2 less than or equal to 45,000. And another restriction is what? Here a restriction is given. There are sufficient ingredients available to make 20,000 bottles of A and 40,000 bottles of B. Okay, so in type of bottles x1, there is restriction will be what? 20,000. So in formulation you see x1 less than or equal to 20,000 and x2 less than or equal to 40,000. So in the linear programming problem you see max z equal to 8x1 plus 7x2, subject to the constant will be 3x1 plus x2 less than or equal to 66,000, x1 plus x2 less than or equal to 45,000, and x1 here this condition less than or equal to 20,000, x2 less than or equal to 40,000. And here x1 and x2 be the number of bottles of medicine A and B. So this is cannot be negative. So x1 greater than or equal to 0, x2 greater than or equal to 0. So in this way, we formulate the linear programming problem. Clear this one? Anybody have any doubt? Okay. So up to this, so from the next class, I shall start how to solve this linear programming problem. Means formulation is given. Okay, directly formulation is given. From this formulation how to find out the unknown means decision variables. So means suppose decision variables in some problem x1 and x2, how to find out the value of x1 and x2. Decision variables is more than 2, then how to find out the variable x1 x2 x3 etc. And here for which problem which method we shall apply appropriately. Means if two variables problems are given, then we apply the graphical method. If more than two variables are present, then we apply algebraic method. This is called the simplex method. So for solving graphical method, there are some procedures step by step, 5 6 step. First we see what are the step, and then we solve the given problem. Okay, so response your name. Okay, thank